Good morning. In this lecture, we will discuss about instruction set of 8086. Why we study the instruction set? The study of instruction set is required to write the instruction in a machine code that can be recognized and executed by a central processing unit. The knowledge will help to write the lines of code or a program by which you will be able to tell the processor the sequence of operation to be performed. That's why we are studying that instruction set. Why we are going to study instruction set? Different types of instruction with example, how to use the instruction in an assembly language program. The instruction sets are classified as a types. Okay, there are 5 types of instruction. First one is the data, copy, but transfer instructions, arithmetic instructions, logical instructions, control transfer or branch transfer instructions, and miscellaneous instructions. Miscellaneous instruction consists of mission control instruction, flag manipulation instruction, and string instructions. Data, copy, but transfer instruction. The example format of this one example is move the destination, source. There will be a transfer of data from source to destination. The source can be a register, memory locations, or immediate data. The destination can be register or memory address. Both source and destination cannot be memory locations or the segment register at the same time. Okay. So after execution of the instruction, the BX contains the source 10 AB will move to the AX register. The next example is push shows. That is, pushes the 16-bit content specified by the source in the instructions onto the stack. Okay. Initially the stack pointer points that 5002. Okay, the 5002 will be the stack pointer pointing. After push operation, the data will be stored in that 5001 and the 5000. Okay. So 5001 stores the data, then stack pointer will be decremented 1, then lower order byte, then again decremented 1. Now the stack pointer points the 5000. Then say pop instruction. Pop instruction, pop destination. Pops the 16-bit content from the stack to the destination specified in the instruction. Okay, so popping operation increments the stack pointer. Okay, so after executing that instruction, the 5000 contains a lower order byte will be moved to the lower order location of the data segment, then incremented. Then 5001 data will be moved into the higher order byte of the data segment, then stack pointer incremented. Again, the stack pointer pointed to the 5002. Okay, previously it is incremented. Next example, exchange instruction. Exchange instruction consists of source and the destination. So same principle, the source and destination cannot be memory locations. The content will be swapped. That is, the AX content will be moved to the BX. The BX content will be moved to the AX after executing that instruction. Next, data per copy transfer instructions are in and out instructions. In contains 16-bit or 8-bit port address in source and 8-bit or 16-bit port address. It copies the data into the accumulator from a port with 8-bit or 16-bit address. Okay, so the port address is 80. The next example, the port address will be stored in the DX register 8000. Okay, after executing that, the data will be stored in the AL register, that is 12. The data will be stored in the AX register 12 and 34 after executing that instruction. The DX is the only register allowed to carry the port address. The next data transfer instructions are XL80. The XL80 means the translate the instruction used to find out the codes in the case of code conversions. Okay, this is a simple program. Explains about the XL80 instruction. The table segment address will be move to the AX register. The AX will be moved to the data segment, and the display code, which code you want to display, that will be moved into the AL register. That offset table contains the offset address. Then XL80 instruction gives the what is the offset of that corresponding display code. Okay, so that this is 7-segment display. The 7-segment display each contains one unique code. 0 means that is 7E, 1 means 30, 2 means 60, 3 means the display is 3 means 79, 4 means 33, 5 means 5B, 6 means 7F, 7 means 70, 8 means 7F, 9 means 7B, A means 77, B means 1F, C means 4E, and D means 3D, and E means 4F, F means 47. Okay, so that code A0X indicate that is hexadecimal number. Okay, so for example, they were previously that AX contains 30,000. That is a segment table segment address that will be moved to the data segment. After that, the display code will be 2. 2 means the corresponding code will be, what is the corresponding code? The corresponding code of the 2 will be 6D. After execution of the XL80 instruction, the 6D will be moved to that AL register. Okay, so the BX register contains offset, that is the initial offset will be 5000. Okay, so after executing that, 6D will be moved to that AL register. Okay, so the display code is converted into corresponding offset code. Clear? Then arithmetic instruction. In that arithmetic instructions are 6 arithmetic instructions: addition, subtraction, increment, decrement, multiply, and divide. Okay, so addition, destination, comma, source. The instruction adds the contents of the source operands with the destination operand. The result will be stored in the destination operand. An example, add AX, comma, B. The source may be immediate data, memory location, or register. The destination must be a memory location or register. AX is the default destination register. If you want to use the AS means, you can address will be simple. Okay, not necessarily AX is the default as a destination register. You can use any register. Okay, so the content will be AX and the BX will be added, and the result will be stored in that AX register. Okay, add with carry. Okay, this instruction adds the content of the source and the content of the destination with the carry flag. Okay, after executing that instruction, the result will be 22,000, 5,000 plus 1, 5,001, the result. Then increment instruction. Increment source is the format. This instruction increases the content of the source operand by 1. The source may be any memory location or registers. Source cannot be immediate data for these instructions. The result will be stored in the same place. So after executing that instruction, 7001. Mul. The mul instruction unsigned operand 8-bit or 16-bit with the AL, and the result stored in that AX and DX register. So the operand may be a general purpose register or memory location. If the operand is a 8-bit, then multiplied by the content of AL. If the operand is 16-bit, then it is multiplied the content of the say AX register. The result is stored in the accumulator. If it is a 8-bit operation, and the result will be stored in that AX and DX register if it is a 16-bit operation. Okay, this is an example of 8-bit multiplication. So the AL register and multiplied with the BL register, and the result stored in that AX register. In this division instruction. Okay, this instruction will divide the unsigned operand AX DX divided by DX. AX is a 8-bit or 16-bit number, and store the results in AX or DXAX. The operand may be a general purpose register or a general memory location. The AL or AX will be operand. 8-bit operand means the result will be stored in that AX register. AL will contain the quotient and AH contains the remainder. For a 16-bit operation, AX contains the quotient and DX contains the remainder. This is a 8-bit division. Okay, AL contains 88 and BL contains the 22. So after executing this instruction, that quotient 4 will be stored in the tail register and the remainder 4 will be stored in that AX register. So AX register. Bit manipulation instructions. The bit manipulations, listen, I forget to tell one. Arithmetic instructions all are affect the status flags. Okay, all are affected. What are the 5 status flags are there? Carry flag, auxiliary carry flag, parity flag, sign flag, and zero flags. So after executing of the arithmetic instruction, all the flags will be affected. These are the some example of arithmetic instruction. Then bit manipulation instructions or logical instruction. These instructions also affected some of the status flags. Okay, we'll discuss about AND instructions, OR instruction, XOR and NOT. AND instruction especially used to clearing the certain bits. Mask. This is used for masking. And source and the destination. Okay, the destination is the BL register. Source will be a immediate data 0F. Okay, so after executing that instruction, we can get 08. Okay, so you just reflection part. You are just studied about the AND operation used to clear certain bit. Which operator used to set certain bit without affecting the other bits? Okay, write your answers. Okay, this is the OR. Okay, so used to multiply each bit or byte with the corresponding bit in the another byte. Okay, or destination comma source. So the destination will be AX register. So source will be at 2000. Okay, those 2000 and AX will be OR. The result will be stored in the AX register. After executing that, okay, the result will be 2008. Okay, OR operation. Then some instruction used to perform that shift operation, that is called SHL. Shift left instruction with carry. Okay, so that MSB will be moved to the carry. The LSB will be filled with the 0. After executing that instruction, destination comma count value. That 5 indicate that is a 5 shift logical shift. Okay, or 1 indicates that is a 1 logical shift, left shift. After executing this, the content will be we previously 5. After executing this, content will be A. Okay, after 1 shift. Okay, after 1 shift, the content will be like this. Okay, shift logical. Okay, so that before that 5, after that. Okay, next example is a control transfer or branch instructions. The control transfer by used to call procedure used to call a procedure and slave their return address to the stack. Example, call label. Return used to return the procedure to the main program. Jump used to jump provided the address to proceed the next instruction. Okay, so these are the conditional jumps. Conditional. The previous are unconditional instruction. Call, return, and jump are unconditional instruction. These are the conditional instructions, branch instructions. Based on the status flags that jump to the specified locations. Okay, first one is jump, the values are equal. Jump, the values are not equal. Similarly, jump on carry, jump on equal. If jump on equal means it checks the 0 flag. Okay, based on that 0 flag, jump, carry flag, parity flag, the result will be either you are going to specific location or will continue that next instruction. Okay, then miscellaneous instruction. The next one is the miscellaneous instruction. Miscellaneous instruction contains mission control instruction, flag manipulation instruction, string instruction. The mission control instruction means does not record any operand. Example, halt, no operation, NOP. Flag manipulation instruction also does not contain any operands. Set carry flag, clear complement carry flag, set direction flag, clear direction flag, set interrupt flag, clear interrupt flag. Then string instruction. String instruction also know that where is the operand. So move string byte, move string word. Okay. So this is a various types of instructions are present in 8086. Okay, this is some examples only I given. For detailed instruction set, we will discuss later. Okay, so thank you, students.